Birthdays can be a lot of fun. With magic shows, children can be mesmerized and kept in rapt attention. Observe this magician performing a trick. He has taken a burning piece of paper, put it inside the bottle. He takes an egg now and places it at the mouth of the bottle. Abracadabra, the bottle is blocked. Is this magic? I have the power of chemistry to unravel this magic. Meet me in the studio to know more about this. Welcome to the episode on gas laws. I hope you are not forcing more eggs into a bottle to crack the question. The answer and more will unravel in today's episode. In today's show, we learn about physical properties of gases, gas laws such as Boyle's law, Charles' law, Gay-Lussac's law, Avogadro's law, and Dalton's law of partial pressure. And there is exam decoded to make sure that you ace your exams. From your previous classes, you know that all you see around is matter, and matter can be classified as solid, liquid, or gas. Today, we will dwell on gases. Gases are all around us, each with different chemical properties. For example, oxygen supports combustion and fans raging fires, while carbon dioxide is used to extinguish fires. Though their chemical properties differ, physical properties of gases are similar. Let me give you an example that will help you understand this better. All of us use LPG or liquefied petroleum gas in our houses, which is a mixture of gases compressed and liquefied under high pressure. Gases exert pressure in all directions equally. Take the example of an inflated balloon. It retains its shape because of this property, otherwise it would collapse. Gases do not have a definite shape and take the shape of the container which they occupy. Gases also form a homogeneous mixture amongst themselves, though the proportions may vary. An example of this is seen in the atmosphere, which contains a large number of gases. After conducting a series of experiments, scientists realized that the gaseous state depends upon 4 variables, namely pressure, volume, temperature, and number of molecules or amount of a gas. The relationship between these variables is expressed in terms of 2 variables at a time, keeping the others constant. The relationships are expressed quantitatively using equations known as gas laws. But before we look at the first among these laws, let me tell you something about the person after whom it is named, Robert Boyle. Robert Boyle is believed to be the first modern chemist, and like the whole of medieval Europe, he was also enchanted by alchemy. Boyle thought of chemistry as a science of composition of substances. He saw elements as the constituents of material bodies that cannot be decomposed, and understanding the distinction between mixtures and compounds, he made considerable progress in the technique of detecting their ingredients, a process which he designated by the term analysis. With gases, he performed various experiments to study the relationship between pressure and volume, and concluded that for a definite amount of gas N at constant temperature T, pressure of the gas P is inversely proportional to volume of the gas V. If we were to express the result mathematically, we can see that the pressure is inversely proportional to the volume. Now, a constant K is added to remove the sign of proportionality. The value of K depends on the temperature, amount of the gas, and units in which P and V are expressed. A different expression of Boyle's law is that the product of pressure and volume is constant, or PV is equal to K. Let's look at the graphical representation of Boyle's law. All pressure volume observations are made while the temperature is kept constant. This plot is known as an isotherm. Iso means same and therm relates to temperature. Hence, isotherm denotes the plot at a constant temperature. Practice makes perfect, and the best way to practice is to solve problems. Let's look at one. At around 300 Kelvin, volume of a certain gas is 112 liters and pressure is 2 pascals. What would be the volume of gas if pressure increases 3 times the initial pressure? Let's apply what we have just learned. At a fixed temperature and known amount of gas, the product of pressure and volume remains constant. If the initial pressure of gas is P1 and initial volume is V1 and the gas expands to volume V2 and the pressure becomes P2, then by using Boyle's law, P1 V1 is equal to P2 V2. The initial pressure P1 is equal to 2 pascals and initial volume V1 is equal to 112 liters and P2 is equal to 3P1, that is 6 pascals. Substitute these values in the equation and calculate V2, which is equal to 37.34 liters. Now that we have studied the pressure-volume relationship, let's look at the relationship between temperature and volume. But before that, let me ask you something. When I was a kid, I was fascinated by hot air balloons. Have you ever wondered what makes them rise? The answer is simple. If air is heated, it expands, and warm air is less dense as compared to the cool air that surrounds it. This difference in the respective densities causes the balloon to ascend. Charles' law states that if the pressure and the amount of gas is kept constant, then the volume of the gas is directly proportional to the absolute temperature, that is, temperature in Kelvin. Mathematically, volume is proportional to temperature. Removing the proportionality sign, a constant K is obtained. Graphically, Charles' law is studied with the help of an isobar. Iso means same and bar means pressure. Hence, an isobar means a plot at constant pressure. The graphs show the variation of volume and temperature for various gases. It can be seen that all of them are different, but they all end up intercepting the temperature axis at minus 273.15 degrees Celsius or 0 Kelvin. This is also known as absolute zero. It's time for a break now, but before you go into the break, why don't you think this over? If the graph at a constant temperature is called an isotherm, then what is an isochore? I'll answer that one after the break. In the meantime, keep thinking. Welcome back. Before the break, I had left you with a question. If the graph at constant temperature is called an isotherm, then what is an isochore? I hope that you have figured out the answer by now. In case you haven't, let me tell you what an isochore is. A graph at constant volume is known as isochore, and isochoric means the same volume. This isochoric is relevant to what we are going to look at next. The Gay-Lussac's law of combining volume. Gay-Lussac's law of combining volumes analyzes the relationship between pressure and temperature when the volume along with the amount of gas is kept constant. It states pressure is directly proportional to temperature. If we were to remove the proportionality sign, then pressure equals K times temperature, where K is a constant depending on volume and the amount of gas. Let's look at a graphical representation of Gay-Lussac's law. By keeping the volume constant, variations in temperature and pressure are studied. The graph is obtained at a constant volume and is known as an isochore. Well, it's time to revisit our magic show at the beginning of this class. The magician had put a burnt paper inside a bottle, and after the fire died down, he placed an egg at the mouth of the bottle, and that locked the bottle. Now, how did this happen? Well, it is like this. As the paper burns inside the bottle and then extinguishes, the pressure inside the bottle is lesser than the pressure outside. The pressure differential causes the egg to lock up the bottle. Clearly, the Gay-Lussac law can stir some magic. It's time now to take a question from a student.
I have noticed that in tires, air is filled to a lower level of pressure in summers as compared to winters, whether it's my bike or my father's car. Can you tell me why this is so?
Absolutely. The answer lies in Gay-Lussac's law and the concept of pressure differential. During summers, the temperature is high, and as the temperature increases, pressure also increases proportionately. And sometimes the pressure becomes so high that the tire cannot withstand it, and so it bursts. That is why air is filled to a lower level of pressure in the summers as compared to the winters. Let's enhance our learning with a numerical. The gas pressure inside an aerosol container is 150 kilopascals at a temperature of 30 Kelvin. What will be the pressure if the can is heated to 400 Kelvin? By Gay-Lussac's law, for a definite amount of gas N at constant volume V, pressure is proportional to temperature given by P is equal to kT. The temperature of the gas becomes 400 Kelvin from 30 Kelvin. This will be accompanied by a corresponding change in pressure represented by P2 from the initial 150 kilopascals given by P1. Now, using equation 3, where temperature reaches 400 Kelvin, the corresponding pressure is 2000 kilopascals. To solve more such problems, you can always log on to our website www.topperlearning.com. All of you would remember birthday parties and blowing balloons. As in other aspects of life, inflating a balloon can also involve some science. But you don't need to worry till the time I am here. As you blow air into the balloon, more air goes in. The volume of the gas increases as it is not only governed by the temperature and the pressure, but also the amount of gas. This is quantitatively expressed as V is equal to Kn and is known as Avogadro's law. Now let's look at the next law. But before that, let me tell you about a big name from the field of chemistry. It was legendary chemist John Dalton who proposed that a mixture of non-reactive gases collectively exerts a pressure which is equal to the sum of the pressure that each gas would exert if it were present alone. Mathematically, we can say that P total is equal to P1 plus P2 plus P3, or the total pressure is equal to the sum total of the partial pressure of each gas. Did you know that this great scientist was also colorblind? However, he did not let color blindness overcome his scientific quest. And yes, color blindness was even known as Daltonism and is still referred to by the same term. Time for a break now, but stay tuned. Coming up after the break is Exam Decoded, where I will tell you just what you need to crack those exams. Welcome back. Over the course of this episode, we have learnt about the laws that govern the behavior and characteristics of gases. Let's go over the main points once more before we proceed. Gases are highly compressible and exert pressure in all directions equally. According to Boyle's law, for a definite amount of gas at constant temperature, pressure of the gas is inversely proportional to the volume of the gas. Charles' law states that for a definite amount of gas at constant pressure, volume of the gas is directly proportional to the absolute temperature. As per Gay-Lussac's law, for a definite amount of gas at constant volume, pressure of the gas is directly proportional to temperature of the gas. According to Avogadro's law, at constant temperature and pressure, volume occupied of a gas is directly proportional to amount of gas. Dalton's law states that the total pressure of mixture of gases is equal to sum of pressure that each gas would exert if it were present alone. And now it's time for Exam Decoded, the section where you can ensure that you get all the marks that you deserve. This is the Exam Decoded segment. Let's begin this section with a test of what you have learnt today with the rapid fire round. This round has 5 questions for 1 mark each, and you have to answer them in a time span of 5 seconds each. Keep track of your scores, because at the end of the round, I'll tell you what they reveal about you. Your first question. The graph which is plotted at constant temperature is called an A. Isochore, B. Isotherm, C. Isobar, D. Isograph. The correct answer is B. Isotherm. Second question. According to the Gay-Lussac law, which 2 variables are related? A. Pressure volume, B. Pressure density of gas, C. Pressure amount of gas, D. Pressure temperature. If you answer D. Pressure temperature, you are absolutely spot on. Moving on. Which 2 variables are related as per Charles' law? A. Volume temperature, B. Pressure amount of gas, C. Pressure volume, D. Pressure temperature. The correct answer is A. Volume temperature. Next question. Dalton's law deals with gases which are highly reactive. What do you think? Is it true or false? This statement is false, as Dalton's law is about a mixture of non-reactive gases. Now for the last question. If I were to use the Kelvin temperature scale, 0 degrees Celsius will be equal to minus 273.15 Kelvin. True or false? The statement is false. Time now to see how you have fared. If you have got all 5 answers right, then you are a high flyer, and this is definitely your strong subject. If you have scored 4 or 3, then you are an achiever. You are doing well, but a bit more practice is needed. If you have scored less than 3, then you are a learner who must keep studying hard to master this topic. No matter how you did in your rapid fire round, do log on to www.topperlearning.com for more questions and test papers. Despite our best efforts, sometimes we end up overlooking some basic facts which end up costing us a lot of marks in the exams. So it is not always about studying harder, but studying smarter and knowing what is likely to be asked and what is to be written as the answer. The topic gas laws is from the unit states of matter, gases and liquids, and has a weightage of 4 marks, which according to me makes it important. Questions asked from this topic are usually short answer type of 2 or 3 mark and will test your numerical ability. Let me show you an example of a numerical question. Your question for 3 marks is, a 250 cubic centimeter sample of neon is collected at 44 degrees Celsius. Assuming the pressure remains constant, what would be the volume of the neon at 0 degrees Celsius? Now let me answer this for you. The volume of gas at 44 degrees Celsius is given as 250 cubic centimeter. The volume to be calculated is at 0 degrees Celsius when the pressure is constant. Thus, this is a case where Charles' law will be applicable. If you know the equation V is equal to kT, this will fetch you 1 mark. Charles' law can also be given by equation 2, which relates volume and temperature at 2 different pressures and temperatures. You have been given the values of V1, T1 and T2. Of these, you must first convert the temperature into Kelvin scale. Ignoring this conversion is a mistake many students make while trying to solve such a problem. The conversion is all the more important because converting to Kelvin will get you half a mark. On substituting the derived values and calculating, you will get the volume V2 as 215.32 cubic centimeters, which will get you the final mark. Remember, only if you write all the steps correctly in your exams will the 3 marks be all yours. Scoring can be made very simple if you practice well enough, but good advice is also helpful. And for that, we have our exam expert to guide you on preparing for your exams on the topics covered in today's episode.
Students, while preparing for the exams, apart from learning the gas laws, try to correlate them with their practical applications. For example, hot air balloons. By now, you know what is Boyle's law and what is Charles' law. But in the exams, you should know which law is to be applied in what case.
There are no magic tricks in this world to help you score, but I am sure that with all the information that you have just got, scoring well will now be fairly easy for you. Visit our website www.topperlearning.com for more insights into your exam preparation. Take the online tests and evaluate your performance. Become your own good luck charm. See you next time.